This is the second part of the full adder series. In this tutorial, we are going to learn about binary addition. The Excel used in this tutorial can be downloaded via a link in the About part of this YouTube video. By now, you should be fairly comfortable with two subjects. The first is decimal addition, adding numbers using base 10s, symbols, and the truth table. If you're still not comfortable with using a truth table, you viewed the first video in this series. With a truth table, we have 3 columns, many rows. The first column is your A input. The second column is your B input. And the third column is the result. The results of carrying a specific operation between input A and input B. Here, we can say that this first row represents input A. The second row would represent input B. And finally, the third row will represent the result of an operation that we carry out with input A and input B. Row A has a value of 1 plus row B has a value of 0. The answer would then equals to 1. 1 plus 0 is 1. Now suppose A is 0 and B is 1. The answer would then be the same, 1. But what if we were to add 1 and 1? In the decimal system, when you add 1 object plus 1 object, you would then have 2 objects. So 1 plus 1 equals 2. So we're going to input A is 1. 1 plus 1 equals 2. Yet, there's a 0 here. Now think about it. Why is there a 0 here? Before we can understand the reason why 1 plus 1 equals 0 here in the M column, we have to make a preposition. And that preposition is that in physics, no two masses can occupy the same space at the same time. So here in this Excel, each cells, for instance M6, L6, K6, each cells represents one entity or one mass. So each cells can only occupy one symbol. So 1 plus 1 is 2, yet this is 0. And the reason for that is that we are doing binary addition. We're not doing decimal addition. So the number 2 in decimal is written as this. In binary, the number 2 is written as 1, 0. This 2 to the 0, 2 to the 1, 2 to the 2. In this column, 2 to the 0 column, 2 to the 0 is 1, and 1 times 0 is 0. 2 times 1 is 2. 2 times 1 equals to 2. 2 to the second power is 4. 4 times 0 is 0. So in binary, the number 2 is represented as 1, 0. So 1 plus 1 is 2. The 0 is here. But where is the 1? So how are we going to solve that problem? We're going to solve that problem by adding a concept we already know in the decimal system, and that is the carry concept. So 1 and 1 is 2, 0 goes here, and we're going to carry the 1 to the next column. Let's implement that carry concept. So 1 and 1 is 2. 0 gets here, and the 1 carries over, and you have 1, 0, 1 plus 0 equals 1. 2. 1 and 1 is 2. What if we were to add 2 plus 1 or 1 plus 2? It doesn't matter what order. So let's give A the number 2, which is 1, 0 in binary, plus 1 equals 3. And we're going to check our answer. 0 plus 1 is 1. 1 plus 0 is 1. And 3 in binary, 2 to the 0 is 1. Times 1 is 1. 2 to the 1 is 2. Times 1 is 2. And you add that together, 2 plus 1 equals 3. So in binary, the binary representation of the number 3 is 0, 1, 1, or 1, 1. Now let's add 1 plus 3. So input A gets 1 to represent the value of 1. Input B gets 1, 1 represents the value of 3. And we get 1, 0, 0 as an answer. Let's double check our work to see if 1 plus 3 equals 4. 1 and 1. 1 and 1 is 2. 0 goes here, and the 1 carries over. 1 plus 0 is 1. 1 plus 1 is 2. The 0 goes here. 1 gets carried over. 1 plus 0 is 1. 1 plus 0 is 1. So you have 1. And to double check if that is 4, you have to be familiar with your binary numbers. Again, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. 2 to the 0 is 1. 1 times 0 is 0. 2 to the first power is 2. 2 times 0 is 0. 2 to the 4 is 4. 4 times 1 is 4. And 2 to the 3 is 8. And 8 times 0 is 0. So 0, 1, 0, 0 is equivalent to the number 4. And we have to remember to add the bottom row. 0 plus 4 is 4 plus 0 plus 0 equals 4. So the decimal number 4 in binary is 1, 0, 0. And that's what we have here. Let's see the carry itself. So let me show carry. The row at the top represents your carry. Each of the cell represents one carry entity. Let's do 2 more examples. The next example, let's add 5 and 2. So input A gets 5, and 5 would be 4 plus 1. Remember, 2 to the 0 is 1, so this gets on. 2 to the 1 is 2, that's odd. 2 and 1 is 3, nope. So 2 to the 2 is 4, so this gets on. 4. 1, 0, 1 represents number 5. Did I say 2? Let's add 3. Let's go 5 plus 3, and 1 and 1. Let's break this down. We'll start with column M. 1 and 1 is 2. You have 2 in binary. 0 gets here, and 1 carries over. We have 1 in the carry. Plus 0 is 1. Plus 1 is 2. So you have 2 in binaries. 1, 0. 0 here. And 1 carries over. In this column, let me change color. In this column, you have 1 in the carry. 1 plus 1 is 2. 2 plus 0 is 2. So you have 2. 0 here. 1 carries over. And 1 and 0 is 1. 1 and 0 is 1. So the answer is 1. 1 goes here. And 0, all leading 0 you could discard. So the answer should be 8. 5 plus 3 equals 8. And again, to check, 2 to 0, 2 to the 1, 2 to the 2, 2 to the 3. 2 times 2 is 4. 4 times 2 is 8. A 1 in the 2 to the 3 column is the number 8. And we have our answer. In our next samples, we are just going to randomly select a number, and we're going to add something to it. So let me select, and the number we're going to select, 10111, is equal to 23. 23 plus 1111, 111111 is 15. So 23 plus 15, we should have an answer of 38. Let's break this down. Now we're going to go to the first column. m. 1 and 1 is 2. We get 2. 0 here. 1 carries over. 1 and 1 is 2. 2 plus 1 equals 3. So you have 1, 1. 1 here. And the other one carries over. 1 and 1 is 2. 2 plus 1 is 3. 1 here. And this one carries over. 1 and 0 is 1. 1 plus 1 is 2. So you have 1, 0. The 0 here. 1 carries over. 1 and 1 is 2. 2 plus 0 is 2. So 1, 0. 0 here. 1 gets carried over. And 1 plus 0 is 1. And you have your answer 1, 0, 0, 1, 1, 0. And double check our work. The number 28 is 1, 0, 0, 1, 1, 0. So answer of 28 is correct. Make sure you download this Excel and play around with it until you become very comfortable with adding binary numbers. Once you become very comfortable with binary addition and truth table, you should be able to fully grasp and understand how scientists takes the idea of binary addition and the truth table and turn it into a working machine.